So this video is going to be talking about the other special right triangle, which is the 30, 60, 90. Again, remember that's talking about angles. So if you notice, we have no angles that are the same, right? 30, 60, 90, they're all different. So we technically, I believe we call this a scalene triangle just because all of the sides are different from each other. For the 45, 45, 90, how we create that triangle is we take a square and we cut it in half, or we draw a diagonal. And so what we do here is we do pretty much the same thing, but except now we don't cut a square. We're going to actually start off with an equilateral triangle. Okay, totally not drawn to scale, but you get the point. Now, an equilateral triangle, right? We have the 60 all right there, right? The 60 degrees, and that's where that one comes into play. And now think about, well, how can we get a 30 and a 90 in there while also creating it as a triangle, okay? And the way to do that is you can draw three different lines. I believe they're called either altitude, median, no, altitude. Let's say altitude, okay? Basically, you take the vertex, or you go from one vertex, and then you basically you go to the opposite side, and you drop a line, and it has to be, and look, this is why we have to do the altitude, it has to be perpendicular to the opposite side. So I'm going to go ahead and draw that. It has to be perpendicular, and that's where the 90 comes from, okay? And now the reason why we work with equilaterals is because this line here, the one that I just drew called the altitude, it's actually nice because since it's an equilateral, it also ends up being I believe it's called a median, which basically does two things. The first thing it does is that it will bisect this angle. So then we have 30 here and 30. Wow, that's super bad. And 30 on this side. And it'll also bisect the side where it touches. So then we actually get this side is equal to that side. It's cut in half. That is very important, right? So keep that in your head. Okay, so let me actually use numbers now, okay? And then if you notice, that already is where the 30 came from. All right, so let's just choose a random number. It doesn't really matter. I will tell you which numbers you will basically easier, okay? So let's say, for instance, remember, always numbers small, anywhere between 2 to 10. And now I'm going to let you, after I do this first example, I'll tell you which, like, there's another little thing of like which one you should choose. So let's say, for instance, I choose 5. Okay, there's nothing wrong with that. It's an equilateral triangle, so that means the side lengths, okay, remember this 5 is talking about the side lengths, is equal to 5. And so now let's look at this bottom part. It's being cut in half by this line that I drew here. And so what that means is this is equal to 2.5, and this one is equal to 2.5. And that right there should be your telltale sign of why you should stop doing this, or why you should stop using the number 5, or not use the number 5. We're eventually going to have to solve the length of this line here that I drew here, and I'm working with a right triangle, and I have two sides, so that means I'm going to have to use Pythagorean theorem and then break down the square root. Pretty much similar to the 45, 45, 90 pattern way. But now we're working with 2.5, so that means you're going to use decimals, and then it's going to be pretty hard to find the patterns like that. So my suggestion is don't use an odd number. Choose an even number. It'll still work. The pattern will still work with an even number. It'll just be, when we get to this part here, like 28, when I'm breaking it down, it'll be way like harder because you're going to have to include decimals as well. And that is extremely, extremely difficult. Okay. So let me go ahead and let's just choose an even number, right? Nice even number. Let's choose 8. Okay. So what that means is this side is equal to 4 and this side is equal to 4. So we end up getting this triangle here. Okay, I'm going to go ahead and draw it. You can choose whichever one of these two triangles. It doesn't really matter because it's the same thing. The only thing that really does matter is where you where the 30 and where the 60 is going. So don't basically lose track of that. This is 30. This is 60. Okay. Really quickly, I want to talk about the side lengths and which one is the longest, the shortest, blah, blah, blah. First thing I need you to completely understand, the hypotenuse, right? That one is pretty much never going to change. It's always going to be across the 90 degrees angles, and technically it's always the longest side of the triangle. Okay, so notice how I said of the triangle. So honestly, since it's always the longest side, we kind of just ignore that and we just call it the hypotenuse, okay? And now, what's really important is looking at these two angles. The 30 degrees is 30 degrees is obviously smaller than 60 degrees. So what we end up basically being able to say is that this side here, the one that's opposite the 30, is going to be considered to be the short side. Now, it's short, it's basically the shortest side of the entire triangle, but we're really just comparing it to this other side, the one that we haven't really talked about. Short side, I've seen some videos, and in class I actually call it the short leg, okay? And so now what that means is that since this is the 60 degrees, that means the opposite side is going to be considered the long side. Or if you want to call it the long leg, okay? Once again, it is not the longest side. The longest side is the hypotenuse, okay? But we just call it the long side when we compare just the two legs. Technically, right, these are the two legs. The hypotenuse, you know that's just called the hypotenuse. So let's go ahead and let me actually use the numbers now, okay? Let me use the numbers. So it's 8 and 4. Let me go ahead and do that, okay? So we have here in this one, once again, don't lose. Where should the 30 go? Where should the 60 go and stuff? All right, so we have that this one is considered to be 8 because remember, it comes from the initial equilateral triangle, okay? So 8, and then the short side is going to be equal to 4, and then we don't know what the long side is going to be, okay? So we have 8, we have 4 here, and then we have no idea, so it'll be an x. Again, we're going to do the same thing as before. We have a right triangle, we have two sides, we're missing one side, so we obviously need to use Pythagorean theorem. So what I'm going to first do, though, is I am going to label my ABC, especially for this problem, because you actually do need it. So remember, the C is the hypotenuse, and then this can end up being the A, and then this one can end up being the B. You can switch the A and the B. That doesn't really matter. The C is the most important. And so the equation we end up using is A squared plus B squared equals C squared, Pythagorean theorem, all right? And so then we can go ahead and we can solve it. So A, in my case, I put it as X. B, I put it as 4. And then C, I put it as 8. Okay, so we just do the work. We get X squared plus 16 equals 64. And now we're just isolating the X, okay? So we get X squared equals, I believe that is 48. Let me check my math. 14, 4, 5, yeah. So then we can go ahead and do the next step, which is square root on both sides. X is equal to square root of 48. Now it's all about breaking down the 48, okay? So let's break down the 48. So you know the next step is to find the perfect square roots. 1 is a perfect square root. 16 is a perfect square root. 4 is a perfect square root. So we have 3 options, and now we just have to choose which one is the greatest or the biggest perfect square root, which ends up being 3 times 16. So I can go ahead and do X is equal to square root of 3 times 16, and then break it down just like we've been doing. Sorry, that's supposed to be like a little dot for times. Okay, times 16. Square root of 16 is equal to 4. We can move the 4 to the front. So then that'll be our answer here for the long side, 4 square root of 3. So I'll put it right here, right? 4 square root of 3. And so now what I'm going to go ahead and do is, just like in the other one, the 45, 45, 90, it's all about the table. Okay, so let's fill out a table, okay? I already have it written here. So go ahead and let me try to explain, okay? This first, what is it called? The column? Yeah, the first column is going to be the length of the hypotenuse. And then the second column is going to be the length of the short side. And then the last column is going to be the length of the long side. Okay, so let's go to this example that we just did. The hypotenuse was equal to 8. Let me choose a different color. The short side, we knew automatically, right? We don't really have to do a lot of work for that one. It's equal to 4, because if you recall from, when this initially started, it ended up, bisecting the side here on the bottom, okay? And so now let's go ahead with the one that we actually did the work for. The long side is going to be equal to 4 square root of 3, okay? So just like the 45, 45, 90 pattern video, I'm going to have you do all of this work again, maybe once, twice, basically how many times you need until the pattern like comes out to you and you can realize how sort of easy it is and why these steps are kind of like moot a little bit. You don't really have to do them every single time. In fact, you don't want to. Okay, so let's remember how we got these numbers. Well, the 8 I just randomly chose when I started with the equilateral triangle. Okay, so that's what you're going to go ahead and do. Just choose another side length for the equilateral and then cut it in half by introducing the altitude, which is also the median, blah, blah, blah. Okay, so let me go ahead and do that right here. Okay, so this is what you're going to do. Start again with an equilateral and then choose a number. We talked about why the number has to be even. If you want, you could do odd, and good luck to you trying to figure out those decimals. I'm not going to do it. Well, actually, if you have the pattern, you could do it. It's actually really easy, but whatever. So even number, let's do 4. Okay. And so then, the next step, let me write 60 in here because we know this is an equilateral triangle. Okay. And then I'm going to go ahead and draw the altitude, which actually also ends up being a bisector, both angle and length bisector. I don't know what I want to call it. Super not drawn to scale. If you notice, look at this side up here, but whatever. Okay, and so then we can go ahead and we can draw the one of the triangles, which ends up being the 30, 60, 90, which we're looking for. Remember, where the 30 is, where the 60 is super important. Before, it didn't matter because both of them were 45, 45, 90, isosceles, whatever. This is different now. So then now I can go ahead and I can introduce side lengths. 4 is equal to this one because it basically represents this side. Okay, that's basically how this becomes really, really easy for some of you guys. Okay, just being able to match. And so then let's go ahead and we know this bottom side here is going to be equal to this one, which if you notice is the short side. And then obviously the last one is just the one right there. So if you need to see it, this one is going to be equal to this one. All right. And so then we can go ahead and we can start putting in another number. Let's see, this one here is going to be equal to 2 because remember it also bisects the length. And then this one here is the one we're going to actually try and solve. Again, Pythagorean theorem, solve for the x. You can do this. Go ahead. First thing I want to do is figure out which one is my c by figuring out the hypotenuse. So that's the c. What I'm going to go ahead and do is I'm going to switch this one being the A now, this one being the B, just so you don't get bogged down with the whole, well, which one is it? Because it honestly doesn't matter. If you notice, they're on the same side of the equal sign, and they're still being, squared, both of them, and they're still being added. So it really doesn't matter, okay? So we get 4 plus x squared equals 16. We subtract 4 on both sides. We get x squared equals, 12? And then we can square root, and then x is equal to square root of 12. Okay, so we have that so far. Now the next step is just, to break down the square root of 12. So let's do, 1 times 12, 2 times 6, 3 times 4, and then it basically stops there because you don't have any different ones where it's just whole numbers. So the 1 and the 4, and so obviously we have to use the 3 times the 4 one. Let's go ahead and break it down. And then we know that the square root of 4 is the one that gets simplified. So we get 2 square root of 3. Okay, the 2 comes from the fact that square root of 4 is equal to 2. And so then we have another basically answer to put in our table. Okay, when the hypotenuse equal to 4, the short side is equal to 2. And then the long side is equal to 2 square root 3. So let me go ahead and let me put that, if I can find it. Oh, boom, there it goes. So we know that let me do that in red. We know that the hypotenuse was equal to 4, the short side was equal to 2, and then the long side was equal to 2 square root 3. After doing this a couple of times, I hope you guys can get the pattern. So now let me show you how it would look in a textbook and stuff like that. So let's imagine, let's see, if I remember correctly, it'll have this one as being the x, the short side as being the x, and then you'll see why right now, okay? So if you know the short side, well, let's think about what would these two blank spaces be, okay? The one that I feel is a little bit easier right now to do is the long side, because if you notice, it'll just be the same number with the square root 3 tacked on right behind it. Okay. And so now that's to get this side. Now to go from here to here, we'll really think about what can you do? Like, do you add, multiply, or whatever? And you really just multiply by 2, because think about it. We initially started with the 8 and then we got to the 4. We did that by, taking half of it. But if we go in the opposite direction, then you obviously have to double it. So we go x times x, right? Which is equal to, x plus x, which is equal to 2x, okay? So the reason why, now let me go ahead and let me explain why we don't do it the other way. Which, I mean, it doesn't really matter. Like, it's up to you, as long as you understand how these patterns work. Let's imagine we put the variable here instead. Let's put y. So we have the hypotenuse, okay, and we're trying to go to the short side. Well, think about it, right? What do we do every single time? We have the hypotenuse. To go to the short side, we divide it by 2. And then now, how do you go from short side to long side using the pattern? Well, you just use the exact same number. So it'll be y over 2 times square root of 3. And that right there is the reason why people don't do it this way. It's just because it looks harder. I mean, it's really not. It's the same exact thing, but, whatever. Whatever works for you, okay? So now let me show you how it would look like drawn, okay, in a textbook, okay? So super not drawn to scale, okay? So I'm going to put 30 here and I'm going to put 60 here. So that means this one here is a hypotenuse, and we already figured out the hypotenuse is equal to 2x. The short side is the side opposite the 30, which we figured out it was x. And then the long side is going to be equal to 60, which we figured out is x square root of 3. Oops, sorry. X square root of 3. Right, so this right here is what you would be seeing in a bunch of textbooks and a bunch of, work and stuff. It's basically just giving you the pattern that you already know, or that you hopefully understand, right? That it's coming from an isosceles, it's coming from an equilateral. This is the equilateral side, right? And then you take half of it to get this one, because by drawing the altitude, you take half of it. And then to get the last side, you basically, all you do is just, you can do Pythagorean theorem there, okay? But what's important, though, is you understand how to go with the pattern, because sometimes you will need to use the pattern instead of using Pythagorean theorem. I mean, there's so many different ways of solving these problems, okay? Let's go ahead and let me very quickly do a quick examples just to show you guys how it can be, okay? So let me do it right here. I don't want that messing with you guys or me. Okay, let's do it right. All right, so quick example. Let's see if I can give you guys, let's give you an easy one first, okay? Because it definitely, the only reason why some of these problems are hard is just based off of how they're written. So here goes a 90. I'm going to put 30 instead here on the bottom, just because, okay? So not drawn to scale, you know the point. And let me give you here, this one is 12. Okay, so this is a kind of easier example. So hypotenuse is equal to 12. One thing I need you to do first, or one thing you should do, is short side. Okay, so I'm going to call this one short side. You can call it short leg if you want to. I'm just call it SS for short side. And then this one here, I'm going to call it long side, because, it's opposite the 60, blah, blah, blah. Okay, so let's think about the patterns, right? Remember, the hypotenuse to the short side, you're doubling it or you're taking half, depending on which direction you're going. Since we have this number and we're trying to go in this direction, it's technically like you're dividing by 2. So what that means is that this short side here is going to be equal to 6. Okay. Now notice how I did not try to go from hypotenuse to long side, because you don't, well, at the moment, right, you don't know what the x is, so you don't know what number to put right, in front of a square root of 3. That's why I went ahead and I got the short side first. And so now what we can do is we can go ahead and we can figure out what the long side is, okay? Because if you recall, the long side and the short side have a really nice, easy relationship. This is the short side, this is the long side. Look at the relationship. You basically just multiply it by a square root 3. So what I can go ahead and do is just put that in here, right? This is going to be equal to the short side times square root of 3. Okay. And so there you go. That's the first basic example. Now, things get a little bit way more complicated if we start, you know, choosing different numbers. So for instance, let me do this here, 3060. What if instead I tell you that this one is equal to 8? Okay. Actually, you know what? Let's make it easier. 12. I'm using the same number, 12. Look where I put the 12 now. It's opposite the 60. So this is technically the long side, right? So if we go back to our table, right, the 12 is going to be opposite the long side. If we go back to our table, that'll technically mean, and let me put it right here in this bottom part. That'll technically mean the 12 will go right here. So you're really going to have to like think about how the heck can I get the short side and the hypotenuse when there's not even a square root 3 though. Like square root 3 there. Like what's going on? And that's why you're going to have to look at the other videos. There's many different ways of solving it. So make sure you guys look at those, okay? But this is where sort of like the really nice pattern breaks down a little bit, and you would have to do extra work, okay?